Before you dive into your next project, there's one question you need to ask. Are you focusing on quality assurance, quality control, or both? If you think they're the same, you might be setting your project up for failure. In this video, we're breaking down the critical differences between QAandQC, and why mastering both could be the secret to delivering a project that's not only on time but meets the highest quality standards. Stay tuned, because by the end of this video, you'll know exactly how to use QAandQC to ensure your projects run smoothly and exceed expectations. Hi everyone, welcome to our channel Next Chair. Today, we're diving into a topic that's critical for project success: the difference between quality assurance and quality control. Whether you are a project manager, an engineer, or someone involved in project execution, understanding these concepts can make or break your project. So let's break it down and see why both QAandQC are so important. In this video, we will first understand what are quality assurance and quality control. Second, key differences between QAandQC. Third, how QAandQC work together in projects. Fourth, the importance of QAandQC working together. And last, common challenges in QAandQC. So, let's get started. 1. What are quality assurance and quality control? Let's start by defining these two terms. Quality assurance, QA, focuses on improving processes to ensure the quality of the product or service is maintained from the very beginning. It's about establishing a set of guidelines, practices, and procedures that, when followed, ensure the product is built correctly. QA is a preventive process designed to avoid defects. Quality control, QC, on the other hand, is all about inspecting the final product to make sure it meets the required quality standards. It's a reactive process where issues are detected after the product has been created. If QA is about building it right, QC is about checking if it's built right. A deeper look at quality assurance, QA. Now, let's take a closer look at quality assurance. QA is about process. It's something that starts right at the beginning of your project. It's not just a checklist that you pull out at the end to see if everything went well. It's embedded into the way your team works from day one. The goal of QA is to prevent defects by improving the way work is done. In practical terms, QA involves things like setting up standard operating procedures, training teams on best practices, and performing audits to ensure that processes are being followed correctly. For example, in a software development project, QA might include things like 1. Establishing coding standards so everyone is writing code in the same way. 2. Running regular code reviews to ensure quality is maintained at every step. 3. Setting up automated testing environments that make it easier to spot potential problems early on. In short, quality assurance is about creating a culture of quality and ensuring that the right processes are in place so you can avoid mistakes before they happen. A deeper look at quality control, QC. Next, let's dive into quality control. Where QA is about the process, QC is all about the final product. It's the practice of inspecting and testing the output of a project to ensure that it meets the expected quality standards. QC happens after the product is made. It involves things like 1. Product testing, whether it's a physical product, software, or even a service. 2. Identifying and correcting defects in the final product. 3. Using tools like inspections, tests, and quality reports to document any issues. For example, in the construction industry, quality control would involve inspecting the finished building to ensure that it meets all safety codes and quality standards. In software development, QC would mean testing the final version of an app or a system to ensure it works as intended before releasing it to the public. QC helps ensure that any defects are caught before the product is delivered to the customer, but unlike QA, it can't prevent mistakes from happening in the first place. 2. Key differences between QA and QC. Understanding the differences between quality assurance, QA, and quality control, QC, is crucial for effective project management. While both focus on delivering quality products, their roles, timing, and impact on the project lifecycle vary significantly. Let's dive deeper into these key differences. 1. Proactive versus reactive. QA is a preventive approach. The goal of quality assurance is to ensure that the right processes and procedures are in place to avoid errors from happening in the first place. It's about building a culture of quality by refining the systems and workflows before production even starts. This could involve training team members, conducting process audits, or implementing quality management systems that ensure things are done correctly from the outset. Example, in software development, a QA process might involve setting up coding standards and best practices at the start of the project. The team adheres to these guidelines throughout the development process, reducing the likelihood of bugs in the final product. QC, on the other hand, is reactive. It focuses on identifying and fixing defects after the product has been developed or delivered. Instead of working on preventing problems from occurring, QC steps in after the fact to catch errors that slipped through the cracks. QC checks whether the end result meets the quality requirements and standards. Example, in a manufacturing setting, QC would involve inspecting the final product after it's been produced. If defects are found, they are either corrected or the product is discarded. It's a way of catching mistakes after the product has already been made. 2. Focus on process versus product. The heart of QA is about refining and improving the processes that lead to the final product. QA is concerned with the how the work is done, how standards are followed, and how the team executes their tasks. This means that QA is embedded in every phase of a project, from planning to execution. It ensures that each step, from design to delivery, is done according to defined standards. Example, in a project to develop a new mobile app, QA would involve creating detailed process guidelines for coding, testing, and design reviews to ensure that each stage adheres to a high-quality workflow. QC is concerned with the what the end product looks like, how it performs, and whether it meets the requirements. It doesn't look at the process of how the product was created but instead inspects the finished result. QC teams will test or inspect the product to verify that it matches the specifications, standards, and expectations set by the client or the project scope. Example, after a construction project is completed, the QC team inspects the building to check for issues such as structural defects, safety concerns, or anything that doesn't align with the original project plans. 3. Continuous versus periodic. Quality assurance is a continuous process that runs throughout the project lifecycle. From the very beginning, QA activities, such as training, process evaluations, and standardization, are implemented and maintained. It's about ensuring that quality is built into the project from day one, making it a continuous effort across all phases of a project. Example, in a manufacturing process, QA might involve setting up ongoing monitoring systems that ensure machines are running correctly and operators are following procedures at all times. Regular audits or process checks would be a continuous part of this QA strategy. QC, in contrast, is typically performed at specific stages or after certain milestones have been completed. This could be at the end of a phase, after a deliverable is created, or before the product is sent to the client. QC happens in intervals or at checkpoints, rather than being an ongoing process. Example, in a software project, QC could occur after every development sprint, where testers review the code, run tests, and check for defects before moving to the next phase. 4. Involvement. Whole team versus specialized team. QA is a collaborative effort that involves everyone on the team. From project managers to engineers, designers, and developers, everyone is responsible for ensuring that processes are followed and quality is maintained. It's an organization-wide commitment to quality, where each team member understands and adheres to established guidelines and standards. Example, in a large-scale construction project, every team member, whether they're architects, engineers, or contractors, must follow the defined quality processes to ensure the project is built according to specifications. The QA focus here would be on everyone adhering to agreed procedures from the beginning. QC tends to be carried out by a designated team of inspectors or testers who are skilled in identifying defects. This team is responsible for the actual inspection and testing of the product. The rest of the project team may not be involved in QC activities, as this is often a more technical or specialized task that requires specific expertise. Example, in a pharmaceutical company, the QC team might consist of chemists or lab technicians who test the final product to ensure it meets safety standards before it's released to the market. Both QAandQC are essential to delivering a high-quality product or service. They may serve different purposes, but they work hand in hand to ensure that projects are completed successfully and meet both customer and organizational expectations. If you haven't subscribed to our channel yet, please do so now. Also, don't forget to like and share the video. Now, let's dive into our next topic: how QAandQC work together. 3. How QAandQC work together in projects. So, you might be wondering, if QAandQC are different, do they work together? The answer is, absolutely. In fact, QAandQC should complement each other. Let's say you are managing a software project. Here's how these two processes might work in tandem. During development, your team ensures that your developers are following best practices, writing clean code, and adhering to the project standards. This reduces the likelihood of defects creeping in during the coding process. Once the code is complete, your QC team steps in and runs tests to catch any bugs or errors that were missed, despite following processes. By combining both QAandQC, you ensure not only that your processes are designed to deliver quality but also that the final product is free from defects before it reaches your customer. While quality assurance and quality control QC serve distinct roles, they work best when integrated as complementary processes. Both are essential components of a robust quality management system, ensuring that products or services meet required standards and exceed customer expectations. The symbiotic relationship between QAandQC. Think of QAandQC as two sides of the same coin. QA focuses on building in quality from the start, while QC ensures that the final product meets the standards set by QA. Together, they create a seamless loop of continuous improvement and defect prevention. When implemented together, QAandQC create a layered defense against defects and poor quality. Here's how they work in tandem throughout the project lifecycle. 1. Early stages. Setting the foundation with At the outset of a project, takes the lead. This phase is all about establishing processes, guidelines, and procedures that ensure quality is built into the project from the very beginning. Example, in a software development project, might set up coding standards, define testing strategies, and establish version control procedures. By doing so, helps prevent defects from creeping into the code base from the start. Example, in construction, the team might ensure that all workers are familiar with safety protocols, building regulations, and material quality requirements. This early focus on process improvement and adherence ensures that the project team is aligned on what needs to be done and how it should be executed. The aim is to prevent issues before they arise. 2. Ongoing development. Maintaining quality with As the project progresses, continues to play a critical role. It's not a one-time task but an ongoing responsibility that spans the entire project lifecycle. Example, in manufacturing, might include ongoing process checks during production to ensure machines are calibrated correctly and operators are following standard procedures. In software, this could involve automated tests running in the background to verify code quality as it's being written. Example, if a software development team notices a recurring bug, the team might update the coding standards or introduce additional code reviews to catch that issue in the future. 3. Post-development. QC comes into play. Once a deliverable is completed, whether it's a physical product, a piece of software, or a finished building, QC steps in to ensure that everything aligns with the project standards and expectations. This is where testing, inspection, and review take center stage. Example, in software development, QC involves running test cases, user acceptance testing, UAT, or stress tests to identify bugs or performance issues in the final product. In construction, this could involve checking the structural integrity of a building and ensuring that all electrical and plumbing work meets regulatory standards. Example, in a manufacturing setting, if a product is found to be defective during QC inspections, it is either repaired or discarded to ensure that only quality products reach the market. 4. Closing the loop. QAandQC feedback. One of the key ways QAandQC work together is through feedback loops. When QC identifies defects, it informs QA about where things went wrong in the process. This creates an opportunity for continuous improvement. Example, if QC finds a recurring bug in a software application, QA can review the coding practices or testing procedures that led to the bug. They can then update the guidelines or training to ensure this problem doesn't arise in future projects. Example, in manufacturing, if a specific machine is consistently producing defective parts, QA might work with the engineering team to recalibrate or replace that machine, ensuring it doesn't affect future production runs. 5. Real-world example, how QAandQC work together in software projects. Let's take a closer look at a specific example in software development. At the beginning of a software project, the QA team sets coding standards and development practices to ensure that the code is clean, maintainable, and scalable. They also ensure that automated testing tools are in place so that each new piece of code can be tested as it's written. Developers follow these best practices throughout the coding process, preventing a significant number of bugs from ever being written. Once the development phase is complete, the QC team runs a battery of tests, including functional testing, performance testing, and user acceptance testing. These tests are designed to catch any bugs or issues that the developers may have missed during the QA process. Any bugs that are found are reported to the development team for fixing before the software is released. After QC identifies issues, the QA team evaluates the coding process to understand why those bugs slipped through. Maybe the automated tests weren't covering certain scenarios, or perhaps the coding standards need refinement. QA then updates the processes to prevent these types of bugs in future projects. 4. The importance of QA and QC working together. QA and QC work best when they are fully integrated into the project workflow. Without QA, you risk introducing numerous defects that will require expensive rework during QC. Without QC, defects might go unnoticed and end up in the hands of your customers, leading to dissatisfaction, additional costs, and project delays. When these processes are aligned, projects benefit in multiple ways. 1. Prevention of defects. QA reduces the chances of defects occurring, while QC ensures that any defects that do slip through are caught before delivery. 2. Higher efficiency. A well-implemented QA process leads to fewer defects, which means less time spent on rework during QC inspections. 3. Cost savings. Catching and fixing defects early in the process, QA, is far less expensive than identifying them late in the project or after the product is delivered, QC. 4. Improved customer satisfaction. By ensuring both processes are effective, you deliver a product that meets or exceeds customer expectations, reducing the risk of complaints or refunds. In conclusion, QA and QC are most powerful when used together. QA ensures that you're building the right way, while QC ensures that the final product is built right. Together, they provide a comprehensive approach to quality management that reduces defects, saves time and money, and ultimately delivers a superior product to the customer. 5. Common challenges in QA and QC. Of course, like any other aspect of project management, implementing QA and QC comes with its own set of challenges. If there's a disconnect between the QA and QC teams or between project stakeholders, quality management can fall apart. Ensuring that everyone is on the same page is critical. QA and QC require time, tools, and skilled personnel. Not investing properly in these areas can lead to subpar processes and defective products. Without clear, documented standards for quality, teams may not know what's expected of them, leading to inconsistencies in both process and product. So, there you have it, the key differences between quality assurance and quality control. While they are often confused, they serve different, yet complementary, roles in ensuring that your projects run smoothly and deliver high-quality results. QA is all about preventing issues by improving processes, and QC is about catching any defects in the final product. Both are essential to delivering projects that meet customer expectations and project goals. If you found this video helpful, make sure to like and subscribe for more content on project management, quality, and leadership. Leave your questions and thoughts in the comments below. We'd love to hear from you. Thanks for watching.